Welcome to the Business of Property podcast. I'm Stuart.
I'm Simon.
And I'm Emma.
And we're all property people running our own businesses. And this podcast is just us chatting every week about the reality of anything and everything property. And this week, we welcome to the show Emma Winfield. Emma is a business coach who supports people that want to downsize and move more towards a low impact life. She also works in the retrofitting field and designing and retrofitting. And if you're anything like me, you've already got a question in your head, which is retrofitting. What is it we are talking about? So, Emma, just for the listeners that might be like me, could you just share a little bit more about when you talk about retrofitting specifically, what that means and how you support people?
So retrofitting is when you're taking measures on an existing building. It's as simple as that. It's just not new build. So you are retrofitting some kind of technology or material to an existing building, usually to improve its performance.
So are we specifically talking about environmental factors or are you also talking about aesthetic factors as well?
The term retrofitting covers everything. I particularly do retrofitting for improving the thermal performance. But really, it's the comfort performance. So it's things that will impact the comfort of living in that property.
Very good. And before we hit the record button, you were talking about the fact that you've been talking about retrofitting properties for around 12 years now. So can you just share a little bit more about sort of your takeouts from that and what we as property investors should be thinking about? Because you asked Simon and I a sort of pertinent questions about insulation before we started, and both Simon and I were a little bit blank-faced. But in terms of insulation, what do you sort of consider the important factors that we as investors should be thinking about really with regards to our sort of portfolios and properties?
Sure. Well, it came up in a property network that we're all members of. Obviously, the fuel increase shock that was looming, this because it's probably 2 or 3 months ago this came up, looking at the April increase and the second increase that's coming in October. And a lot of people in that property group have properties that they're holding long term, and they are HMOs. So they've got people living in them whose rent includes all their bills. So I think that's always been a bit tricky for HMO landlords.
Definitely.
Figuring out how to find the balance between the property being comfortable to live in for the tenants, but also mitigating behaviours that just cost the landlord and don't add to the comfort of the tenants. So leaving the heating on all day when they're out at work all day. We've had a lot of discussions over the years about things like, or heating controls is the big one, because in terms of fuel use, heating is the big one. Anything that has an element in. So that's your kettle, that's your hairdryer. Those are the things. Your washing machine, because they now self-heat rather than using your hot water. Then obviously the central heating. They're the big things that can really impact on the bottom line for an HMO owner. And I guess the more rooms, the worse that can be. I don't have an HMO, but picking up on what comes up in that group. A lot of the conversation has been about heating controls. So originally they were relatively blunt instruments where you almost locked down the controls that are on the wall for the tenants. There's one that I've seen a few times. The tenant can press a button to put the heating back on for 1 hour, 2 hours or 3 hours, and then it just automatically cuts off. And they would have to then go back to the box and push the button again. So if somebody was home all day in the winter and needed the heating on, they would have to physically go and keep restarting that. And I think that a lot of those boxes also set a maximum thermostat temperature.
Yeah, like thermostats.
Yeah, whereas obviously now there are more, they're called intelligent, as in artificial intelligence. There are smarter controls that you can retrofit, there's that word again, For example, I've got a Worcester Bosch boiler in each of my units. They originally had very ordinary controls, and now they can have smart controls. You can set the temperature, you can set the program across the week, you can lock it down so that the tenants can't do anything with it, or you can have it completely open. I can control it remotely from an app. My agent can control. So in terms of controls, I think we've got the tools now to be managing the heating as best we can in that sense. But you can only go so far with that. Whereas if you insulate your property really well, the maximum energy use is so much lower that you actually get less anxious about trying to manage controlling how many hours it's on for and what temperature it reaches. I have 2 units, one of which I can't do very much more with, and the other of which I've done the absolute maximum to.
In that sort of sphere of insulating, and sort of that being sort of the base to build on, where do most properties that you see sort of start from, and what can be done to improve them? And indeed, when you get to that level of you've done the maximum, what is the maximum? Could you sort of run us through the range, please?
So the starting point is insulating your loft. And often people in property make an assumption that, of course, everybody knows that and everybody's done that. I don't know the statistics without Googling it again, but I know that the percentage of homes that haven't got the bare minimum of insulation in the loft, even after, the 3 rolls for the price of 1 offer that was backed by energy companies in all the DIY stores, government grant systems in the past. It's surprising, but there is still a vast percentage that don't even have that. So that's where you would start. If you are in property and you've just purchased a new place and you want to go in and, sort of do an assessment of the state of the building on all levels, when you're looking at energy use, it's stick your head up through the loft hatch and see. And even if it does have, the rolled out soft insulation between the joists and there's no flooring down, it's a regular old, what we call a cold loft. Because if you put the insulation between the floor joists of the loft, you're keeping the house warm and you're keeping the loft roof area cold. And there's a very good reason for doing that, because it's the simplest way of keeping the roof joists, all the timberwork in the loft, in really good condition. They've got airflow. They're not dealing with lots of change of temperature. They haven't got warm air condensing on them. So that was the norm. So for starters, many lofts don't even have that. Then the next level is the people that did do that 30 years ago. That insulation may by now be completely weighed down with dirt and debris that's fallen, depending on the condition of the loft. And sometimes it is necessary to, fit yourself up in all your protective gear and go and roll it up tight into bin bags, dispose of it and put new stuff in, because the product itself doesn't do the insulation. The product is a matrix of fibres that contains masses of air pockets, and it's the air that's doing the insulation. So you can have either no insulation or old insulation. So that's like the minimum. If your loft is done and it's relatively new and you come down to the rest of the house, it is pretty property dependent as to whether you start looking at the internal surface of exterior walls or the floor of the ground floor. So if you've got a Victorian property with suspended timber floors, with air bricks that are still open and haven't been cemented shut, You might have drafts coming up, especially if you haven't got any carpet fitted. You've just got rugs and bare floorboards. So in that case, it's very effective and it's a DIY job that you can do. Well, there's two. The easiest is you can buy a product that is, it's basically a rubber string, for want of a better word. So it's, round, small diameter. I think it comes in 3 sizes on a reel. You go and you line it up with the gaps between your floorboards, the right size for the size gap. And it has this funny little plastic wheel that you just roll over it and it pushes it right down into the join between the floorboards. It's a perfect seal. And you just simply put something down and hook it up and strip it out if you ever wanted to remove it. Unhelpfully, I've forgotten the name of the product. But I will have a look and get it to you if I find it.
Excellent. We'll put that in the show notes.
And then if you want to actually insulate it, you would lift your floorboards. You'd get roofing membrane, because it's the most cost-effective way to do it. And roofing membrane has a right side up, if you like. So one side stops all liquid moisture and the other side allows vapor moisture to pass through it. So you use that membrane upside down, as it were, with what would be the roof facing side facing downwards to the earth, and you staple it to the top of your first joist, and then you let it drape between the joists like a hammock, and then over the next joist, drape into the next void like a hammock. And you can staple the hammocks to the sides of the joists. You do that, and then you just roll in that same loft insulation between your joists, and you put your floorboards back down. And now you've got an air membrane. So you're stopping all the drafts with the membrane, and you've got insulation. And the improvement on the feel is significant enough that people routinely report we used to have to put off the thermostat to 23 degrees. Now it's comfortable at 19. Like, it really does have a big impact.
And is that just on the ground floor rather than sort of every floor on multi-floor properties?
Yeah, because the ground floor is where the outside air is coming in. You've got difference in air pressure differences is sort of what makes it move.
Yeah, so that sounds really good. Sort of underfloor heating without any actual heating.
Yeah, well, or at least getting rid of the underfloor monster sucking the heat away. I mean,
exactly. What I meant is it will make the floors feel warm.
Yeah, and the whole room. I mean, in fact, the whole house, because if you can. So this is the interesting thing about insulation. Insulation is part of a trio, and I call it a dance because it is a bit of an art. There is a lot of science behind it, but it is a bit of an art per property. It's a dance of 3 things, which is insulation, draught proofing, and ventilation. So you want managed ventilation for air quality, but you don't want drafts, because a draft sets up a perception of being cooler than it really is. And that's when you keep tweaking the thermostat up and up. When your thermostat says 23 and your heating is, churning away, it's not a real reflection of the temperature in your house if you've got drafts. If your property was perfectly draft proof and fully ventilated, the number of air changes per hour, and it was at 23, be in your swimming trunks looking for a cold shower. It's just not, it's not a temperature we really want to live at, but a lot of people, that's where their thermostat's at.
Yeah, I know that feeling well. I live in a relatively new build house, and yet its thermal control is a bit rubbish. I mean, the room thermostat is on the middle floor, and in winter, our middle floor is fine, our top floor is fine, but our bottom floor is freezing. And I'm pretty sure this is actually because our bottom floor is full of leaks and drafts, as you say, rather than any kind of managed ventilation. When you talk about managed ventilation, How do you do that without just making it a draft?
Well, the product designers do that. I don't know. But so I spent the majority of the time that I was working actively as a builder and as a designer of retrofit projects. And I actually, for a period of time, had a shop selling natural building materials. I haven't mentioned that actually. I focus specifically on low impact retrofit and low impact all round. So using natural materials and working with the breathability of solid wall buildings. That's because I was in Bristol when I first really got into this, and I was in a brick Victorian terrace surrounded by brick Victorian terraces.
So in those Victorian buildings, how did you secure ventilation? So presumably you had a whole heap of drafts that you needed to fix. And once you'd fixed those, what did you do to put in the ventilation that you then need, assuming you did do this to those buildings? I mean, I've heard of things like sort of heat exchanger type things that capture heat on the way out. And do you need to get that technical, or are there simpler approaches?
When looking at an ordinary mid-terrace Victorian house, I've discovered that it is in fact enough to use a single unit that's loft mounted and has its sort of grill opening to the house in the ceiling of the hallway upstairs. And you can use one unit to manage the whole house. And it is doing heat recovery because it might as well. It's not that complex for it to do that. So it's removing humidity and it's refreshing the air. So you're getting rid of the stale air and bringing in fresh. So your oxygen levels and your CO2 levels are nicely managed.
So that would have a grill in the hallway ceiling, and that would effectively be sucking air into it from the house.
Yeah.
And then doing its magic and sending it out through the roof.
Yeah. And it's doing it at a rate that you don't feel. So a draft is something we can feel. And even, I'll talk in a minute about trickle vents. I'm a fan of them in many situations because there are many situations where you can't put in a ventilation system. Like I've split a Victorian terrace into 2 units. So the top unit is a maisonette on 2 floors that can have one of these units in. But the ground floor apartment can't take advantage of that. And it's quite strangely constructed in such a way that there isn't really a wall space even where I could fit one that would work well. So I do rely on trickle vents in the windows. And Part L of building regs no longer specifies that you must have trickle vents. So again, it's something you have to request and design in. Because if you do have a house that has mechanical ventilation, you don't want trickle vents. And if you don't need trickle vents, you don't want the manufacturer of your windows to go piercing holes through your, highly efficient, triple glazed, etc. windows. So that's what I say. It's always a bit of a dance with the building that you've got and what you're trying to achieve and what's possible within the structure of the building and your budget, really.
So going back a tiny bit to this loft-mounted device that's sucking air out of the house. If it's taking air out, is it also putting fresh air in as well, or
yes.
does that?
Yes.
So that's all within the one device, is it?
Yeah, because that? if it wasn't, then your house would be searching. The new air has to come from somewhere, and it would be pulling. That's why you have to do all your draft proofing before this system will work, because as it's pulling, every leaky bit will be letting new air in and it will be letting cold air in, whereas this device takes just through a series of metal fins that the air sort of passes through a corrugation of metal, and the outgoing air is on one side of this lovely fin-shaped thing, and the incoming air passes over the opposite side of the same fins coming in, and so it's preheated, so it comes in at the same temperature as the air leaving. And the reason for that is by maintaining a constant temperature, you're avoiding condensation, where you've got warm air hitting cold surfaces. You're not cooling any surfaces down. So if you had cold air coming in, you potentially start cooling down windows and then having that temperature differential. So it is complicated. I'm looking at your. It is complicated, and that's the biggest hurdle for a homeowner or a landlord. But if you do it incrementally, say on one property, you just do one measure, you'll learn through doing that. And I think you could quite quickly gain the confidence to get yourself to a point where, especially every new property you take on, you're putting these measures in automatically.
Yeah, exactly. I think it needs to become second nature for more people to understand them, both landlords and homeowners and builders as well, to be able to actually, as you say, put these in automatically. I've got two avenues of questions I want to ask, and I'm concerned that whichever one I ask, we're going to go down a new rabbit hole, and I'll forget to come back to the other one. But I'm going to plump for one. You talked about doing this to a Victorian house, which has got floorboards on the ground floor and then a void and then soil underneath, basically.
Yeah.
What can be done for slightly newer properties that have got concrete floors? Because obviously a lot of properties do. Yeah, is there anything that can be done to insulate those? I mean, obviously if you've ever been in a concrete floored house without the carpet down, the concrete feels cold. So I assume it is busy leaking warmth. Yeah,
so my parents, I helped them move 5 years ago now, somewhere between that. They bought a chalet bungalow with the 2 bedrooms sort of up in the loft space and not very much ground floor space. And my mum's not very mobile, so they needed all ground floor living. And it had a big enough garden that we knew we could double the size of the downstairs. So the new build part is an insulated concrete slab with underfloor heating. But the existing part of the building was also on a concrete slab. We did drill some holes through to check, and the slab was definitely not as thick as we would have had it, and we actually found a couple of voids. But they didn't have the budget because to really do this properly, and this is why with retrofit, you're always making a decision on what compromises you're happy with. To take the slab out and then pay for the waste removal, that's the big expense, skip after skip after skip full of rubble. It was beyond their budget. So what I did is took all the flooring off that was there. We spoke to the neighbours who all had similar builds, and they've all tried various things, and they all said their floors were still cold. So I knew we had to do something quite serious about it. So in the end, we put liquid bitumen down. I think it's called Blackjack. It's just a product you buy in a tin, and it is like sticky tar. And we painted that down onto the slab, because that then works as a damp-proof course, because that's a lot of why they're cold, is because they're drawing up the damp. Then we stuck, I think, 30 mil of insulation, just pushed it into the Blackjack, stuck like crazy. I used cork because that's what I use. You can also do it with ordinary PIR, so a Celotex type product. Glue it down. Then you tape all the joints. Now you've got damp course and no air coming through. You've really built and braces that. And then they just put their floor. Then we did a deck of, I can't remember now whether it was ply or OSB. You can use either. Just floated on top. And then they put their LVT luxury vinyl tile, very hard wearing vinyl flooring on. And the neighbours are completely bowled over and very jealous because it's worked. And that was our test, was to get all the neighbours in to come and sit. So then in those spaces, they've just got radiators, but they don't have cold floors. My parents never have their shoes on.
That's impressive that you've achieved that without heating.
Yeah, well, they notice the difference between the heated floor if it's in a period of heating up. But once it's to temperature, they can't notice the difference underfoot. And the two parts of the building are open, so you just flow from one to the other. There's no thresholds. The flooring just flows through. They don't notice it. And my mum is one of those people that's always complaining about cold feet, and not now. So
sounds very good. You mentioned the different layers you put in there, and my math is probably out, but I think you're saying you used up sort of 5-6 centimeters of space with the extra stuff you put in. Is that sort of not noticeable?
It was, but luckily we had the height for the doors. We had the door height. So it was 30 mil insulation, 18 mil for the deck, and it's about 3 mil by the time you've done your levelling screed and put your LVT in. So that's 51-ish mil. Yeah, we had the height, luckily. So we bought solid doors so that they were very easy to alter the size of. My parents were dubious. They thought, can't you just put, like underlay down or something? And you can Google and you will find products that are 3 to 5 mil thick that will tell you they will do the job. And I looked into whether any of them had testing and data sheets, and I couldn't find products that actually had certified lambda values that I could calculate.
This is perfect. You brought things round to the other avenue that I was wanting to ask about. So I was going to say, how does this sort of feed into EPCs? And talking about sort of the hammocks with insulation in, are they recognised and will they improve your EPC? And similarly, the other approach with the concrete floors and things. I mean, obviously, your parents probably aren't too concerned about achieving a good EPC, but as landlords, often that's unfortunately critical. So yeah, how does it feed into that?
So I haven't actually had an EPC done yet for my parents' house. And one of the reasons is, so an EPC is an energy performance certificate. And there are people who train to come round and assess the fabric of your building, literally the fabric, the materials your building is constructed of and how it's constructed. And based on the set of materials, you get a grading. There's a major flaw with that in that those materials can have been installed poorly, and you can have all the right materials and the place be so drafty that it's not actually performing, but you've got a brilliant C on your EPC.
Just like my house, but don't tell anyone who wants to buy it. But anyway.
Yeah. But another difficulty when you're wanting to use natural materials is the natural materials are tested in labs and have the same data sheets with lambda values, U values, R values. It's all there. But your average person who's doing EPCs that just trained to do EPCs and they're not part of a much larger business that's doing energy performance stuff, they will have software in their computer that's called SAP, and I can't remember what SAP stands for, but it's a database of the materials and the lambda values. But they will have a smaller set of data. They have a subset of the full SAP for every material. For me to have an EPC done on my parents' house, I need to find a company that will do an EPC with the full set of SAP data in so that they can select, for example, the cork. An ordinary person doing EPCs can't select cork as a material. So for landlords, although my passion and what I focus on myself is natural materials, for a landlord, I specify standard materials that will be in the standard subset of an EPC. what are they called? Inspector or measurer? I don't know what they're called. But someone that's doing EPCs for you as a property owner, landlord, you really need to use the very standard conventional materials. Comes with its own different set of risks because it's quite complicated. If you put insulation on your inside of your wall, you make your wall thicker, obviously. But the physics that has to be calculated by somebody is where the dew point is in your wall. And the dew point is the point at which the outside air temperature that's cool meets a warm enough temperature that air will let go of the water that's in vapor form and it will produce droplets. And you don't want that to be on the inside face of your brick or block wall. You want it to be somewhere within the solid structure of your wall and nowhere near the inside, and definitely not getting trapped between your insulation and your wall, because you will put that insulation on your wall, but then think all the way down to the floor level. It's going to be physically sitting on top of your joists. So you cut your floorboards back to take the insulation, preferably. Some people don't, they just put it straight on the floorboards, that's okay. But it is sitting on your floor joists. And if you end up with too much moisture hitting the back of your insulation, it will move down to your joist and ultimately your joist can rot. It's a complicated business, and that's why I only work with breathable materials, because you can't have that problem. But SAP doesn't recognise them in the subset of data.
Yeah, having water in the middle of your wall sounds like a bad idea.
Yeah, you see, this is exactly what happens, though, is you set out wanting to do something positive, and it's such a learning curve. You do reach that point where you go, I can't see a way forwards. And it's finding someone you can work with that can help you find a way forward that suits the property you've got and the budget that you've got.
You mentioned lambda values and U values. Could you give us just a really dumbed down idea of what these things are, just for my benefit?
I can give you a very dumbed down answer because I don't know the calculations behind them or the physics or how they're even produced. I simply read them.
And just a quick one, what is lambda when we're talking about lambda? Because that was something I was going to ask earlier on.
I think the lambda value is the pace at which, or maybe it's just a value where heat moves through that material from one face to the other. You know, with insulation, it comes in different depths. And that's where your U value comes in, because your U value is sort of taking that rate per mil of depth. I don't know what measurement the lambda works off of. It's taking that and then calculating it out. If you're putting in 40 mil of insulation, calculating what the actual impact is in a real life situation with something that is 40 mil deep. And so you will see a different value for a 25 mil PIR board, like a Celotex or a Kingspan, and the 100 mil one will be different because it is thicker. So you have more of that material that has its base rate of movement. Yeah.
And for someone simple like me, low lambda value is good, high lambda value is not so good. So we want the lower the value, the better it is for insulation.
Yes, that's true. But if you just look at materials lambda values and you went for the lowest, it all depends on your building as to how much room you've got and to what the material is and what thickness that material needs to be to reach the U value that you have to meet for building control if you're doing a new build or a significant percentage extension. So for me, sometimes I'm actually ending up with a less good U value, but a better set of materials for the property. So overall it will perform better.
Yeah.
I mean, I appreciate I'm not giving you really straight answers, and that is the crux of the matter. Because there aren't off-the-shelf straight answers, that's why people aren't doing this. It's not through lack of will for many, many people. And alongside that, one of the difficulties is that a builder in the UK does not have to have done any formal training whatsoever to be a builder. They may have done, and they may have done extensive and repeated and renewed training, but they don't have to have done any formal training. They may not know about U values and depths and how materials perform against each other. And again, not through lack of will. Their only source often of education is when they're standing at the trade counter of a major materials supplier who has something on promotion. Now, the trade counter's job is to sell product. It's not to know technically which is the best product for them to use. So one of the things that's happened with solid wall properties, it may also be happening with cavity wall properties, I'm not sure, is builders have been told by material suppliers that in order to insulate the cold room in your Victorian terrace, you know, the L-shaped room that sticks out the back and has got two external walls and its own little roof, it's always the problem child of a Victorian house, they'll say to them, oh, put roofing battens on the wall so you're battening off by 25 mil, then plasterboard it with polystyrene backed plasterboard. One, that's not a very insulative product. Two, when they talk to you about it, they'll always say, oh yeah, I've battened it off so it's got a vented void and therefore there will be no build-up of condensation. And when you say to them, oh, how's it being vented? They just go, yeah, 25 mil battens. You go, yes, no, but you said vented. Yeah, it's a vented void. And you go around in circles because obviously it's not a vented void.
What they mean is they just left some air there, but there's no way in or out. It's just some air there.
Exactly. And so because there's no air flow and there's no air pressure change, there's no way for that moisture to dry out other than warmth somehow penetrating through your solid wall. When I really, really tried to dig into if there was a way to ventilate, so my Victorian terrace is a double skin brick wall. The skins don't line up, obviously, and the mortar joints don't line up. So even if I dug out mortar between two bricks and put in what's called a brick weep, which is like a plastic fillet with a little runoff channel at the bottom, literally for any moisture to drip out of, that would be fine if the dew point is between my first brick and my second brick. But if my dew point is behind the second brick, how does one vent that? The only way I could think of is you literally have vents in the room at the bottom of the wall and at the top, but you'd have to have them for every void between every batten because the battens effectively close that void, if you see what I mean. So I didn't think that was a very workable answer. And the more I dug into it, the more people in the know said it's dreadful. You do get it condensing on the back surface of that polystyrene backed plasterboard, which is often a foil. So it's really easy to hit it, down it runs onto your joists, and then you have this problem of water on your joists.
So that's a bad idea. What's the good idea?
Well, I actually then went and removed some boarding that had been done like that on a single skin wall of mine in my Victorian terrace. And as we had all predicted but didn't know for sure, it was damp, but it was also full of black mould, which is the bad stuff. So I still needed to insulate the internal surface of the external walls of my Victorian terrace up on the first floor. And I just had to make a guess. And sort of suck it and see and decide what I was going to do. And what I did is I did a full adhesive layer on the back of insulation backed plasterboard, proper insulation rather than just polystyrene, so that it then fitted onto my wall in a full bed of adhesive. So there was no void because the void increases the chance of the condensation, if you like. So I've now got a skin of brick, this thin layer of adhesive, which is also supposedly a damp-proof course. This is all theoretical unless I rip the wall apart, and then straight onto the insulated plasterboard. And I was just taking a punt, really, that it's not easy for moisture to get through that adhesive. And then even if it were to, it can't literally run down anything. So my hope is that the external air pressure will do its job through capillary action of sucking that moisture back out. I haven't had any visible problems in the house. I can't tell you, short of pulling it apart, whether that was the thing to do. In the garden apartment, the ground floor, I took it all back to brick, and I've only used natural materials. Because there's more pressure from ground damp, I wanted to really work with the building rather than work with the EPC on the garden flat. So I've insulated the walls with hemp and lime to varying depths depending on which bit of the wall, between 60 mil and 120 mil. And then I've clay plastered. And the clay plaster gives me like the fourth partner in the dance of thermal mass. But that complicates things even further. And what that means is downstairs, my walls act as a radiator. The whole of the wall acts as a battery, storing heat and slowly giving it back off to the room. And the heating is provided from underfloor heating, which is in an earth slab, on a hemp lime slab, on a foamed glass insulation and damp-proof layer. And it has a terracotta tile finish because I turned it into a holiday let, so it needed to be more robust than a polished earth finish. That's way too far for most people to go.
Well, I have to say, Emma, I've almost got writer's cramp from the amount of notes that I've been scribbling down from what you've been talking about. And I also think my builder's not going to be a fan of yours because he's actually been talking in one of my properties about doing the very thing you've talked about in terms of the two battens and putting the plasterboard across it and creating that void, because we've got damp issues in a sort of basement level. So it's been extremely educational, this particular episode. And we're really grateful that you've been able to come and share what is clearly a lot of experience and knowledge with us and our listeners about this. And no doubt, I'm sure they'd love to see you back on a future episode so that maybe we can talk a little bit more about some of this, because it's been great. As we have reached the end of our episode, it just leaves me to say thank you for coming and joining us today, Emma. For those that would want to reach out and get in touch with you, what's the best way for them to do that?
Email is probably the best way. My email is emma@slow.org.
And that's slow.org.
Yeah.
Fantastic. And as per usual, other than that, if anyone wants to contact us or join in a conversation about the topics we've talked about today, all of which are clearly as important as they've ever been, given the energy sort of crisis that we're facing, please reach out to us at BIZ of Property, at Biz of Property on Twitter, or contact us, as some of you have done recently, via www.thebusinessofproperty.com. And other than that, we will see you on the next episode.